Imagine spending hours machining a perfect-looking part. The dimensions are correct. The tolerances are within spec. Everything seems perfect. But when the customer installs the component, it wears out faster, leaks under pressure, creates excessive friction, and fails long before expected. What went wrong? The answer isn't hidden in the dimensions. It's hidden in the surface finish. And today, you'll see why two parts that look identical can perform completely differently in the real world. The hidden difference. Most beginners focus on dimensions. They measure diameter. They check length. They verify tolerances. But experienced machinists know something else matters just as much. The quality of the surface itself. A surface may appear smooth to your eyes. Yet under magnification, it can look like a mountain range filled with peaks and valleys. These microscopic imperfections affect how a part performs. They influence friction, wear, lubrication, sealing, fatigue life, and even appearance. That is why surface finish is not simply about making a part look beautiful. It's about making it function correctly. Real comparison. Let's compare two shafts. Both are machined to exactly the same diameter. Both pass dimensional inspection. Both are made from the same material. At first glance, they seem identical. But shaft A has a rough surface finish. Shaft B has a fine polished finish. Now install both into precision bearings. The rough shaft creates more friction. Heat begins to build. The bearing experiences additional wear. Lubrication struggles to remain consistent. Over time, performance drops. Now look at the polished shaft. The smoother surface allows better contact. Less friction is generated. Lubrication performs more effectively. Wear is reduced. The component lasts significantly longer. Same dimensions. Same material. Completely different results. That's the power of surface finish. How do professionals achieve better surface finishes? First, they use sharp cutting tools. A worn tool often creates poor finishes and inconsistent results. Second, they optimize feeds and speeds. The wrong parameters can leave visible tool marks and rough surfaces. Third, they control machine vibration. Even small vibrations can dramatically affect finish quality. Fourth, they use proper coolant strategies. Heat control plays a major role in achieving consistent finishes. And finally, they measure. Professionals don't guess. They use surface roughness testers and inspection methods to verify results. Because what gets measured gets improved. Curiosity. Here's something fascinating. In many precision industries, improving surface finish by only a few microns can dramatically increase component life. A change so small it's almost invisible to the human eye can mean the difference between a part lasting months or lasting years. Think about that. A microscopic improvement creating a massive real-world advantage. That's why elite manufacturers obsess over details most people never see. The smallest surface features often determine the biggest outcomes. Conclusion. Surface finish is far more than appearance. It affects performance, reliability, efficiency, durability, and customer satisfaction. The next time you inspect a machined part, don't stop at the dimensions. Look deeper. Because sometimes the difference between failure and success is measured not in millimeters, but in microns. If you found this valuable, like the video, Subscribe for more CNC machining insights and share your own experiences with surface finish challenges in the comments below.